Hey everybody, Vade here, back again with another application problem. In fact, the last one was not really an application problem because it's just on the Cartesian plane. You're given a function and you're asked to just a rectangle is like inscribed in it. Like, I wouldn't really say it's like application, but this is like actual application. Like, we got the U.S. Postal Service involved in this. Like, I mean, that's kind of like application-ish because, you know, they're delivering the mail, and that's like real world, not on the Cartesian plane. Yeah. Anyway, before we start here, this I know you see parts B and C. You're probably like, why did I cross that out? Well, it's really because once you know part A, which is the part which people probably are going to struggle with the most, B and C are pretty easy to do, especially since you're given that you get to use a graphing utility, right? So like it's your Desmos, or if it's like a test question, your TI-84, So it's again, and I really appreciate them for introducing you to like what dimensions will maximize the volume of the package, because this is stuff you will be doing in calculus without the graphing utility, and just sort of letting you explore that concept. And I always allude to it in these types of videos. Like the last one, I was talking about it for at least like 3 minutes, like about how, oh, if it were to ask you, like it'll ask you to find the relationships, which students often struggle with the most, but then it'll add that third or fourth or whatever additional step of like finding the maximum or minimum of something, like depending on the context. But again, the reason why it's so important to understand these types of problems, and I said this in the last video, I'm going to say in each and every video, is because you will be expected to find these same exact relationships. If not, I mean, I wouldn't really say it's necessarily, more challenging, but, these are challenging already. Finding these geometric, analytic, geometry-ish relationships. I don't know why I'm really hesitating there. These, like, geometry relationships, um, you are expected to know how to do that, and you will have to know how to do that. You will have to find the relationship between, the geometric relationship based off of the given information. You will need to know how to do that in order to then find that maximum volume, or whatever it is, depending on the context, because you will need to have that function, because then you'll be doing calculus, etc. So that's why very important to master this early. And you guys have these skills. That's why we need to practice it. You guys have done geometry already. You guys have learned this. So we're just applying it into the calculus, pre-calculus sort of, how do I say this? The pre-calculus version of this, okay? And this is, again, people struggle with this a lot, so it's better to master this early. Let's start with the problem now. So a rectangular package. Again, really lucky that they're giving us the picture here. Okay. Um, in fact, I think they have to give us a picture here. If not, they'd have to tell us the length is y, the width is x, and the height is also x. So they'd have to give us all of that. In some ways, actually, the picture may make it a little more complicated, because some people do not really know this, but the length is actually the longest side of like your rectangular prism. Okay, same with a rectangle as well. Like the length is always considered the longest side, so y would actually be the length. Okay, some people may think, oh, I can, like, if since v equals to length times width times height, the width could also be the length, or the height could also be the length. That's actually not true, because people denote length as the longest. That's just, like the formula works out, luckily, like it's just multiplication, but in technicality, especially when they ask for dimensions, again, we're not going over that. You will have to list it in this order. So if it's out of order, then it's technically wrong. So again, that's why maybe it makes it more complicated. I don't know. But it can have a maximum combined length and girth, perimeter of a cross section of 108 inches. So we're gonna get to girth, the vocab, because that, again, this part may seem a little confusing Maybe you've not heard of girth. So um, we're gonna go over that in just a second. Um, and it says 108 inches. We're gonna come back to that. Okay, let's first look here. What is the volume V of the package as a function of x? Okay, so volume. This is length. I'm just gonna say here. This is length. This is length. Okay, remember because y is the longest, length is longest, and then width is x, and height is also x. I'm going to just say this is w, and this is height, h, height. So then, of course, volume v equals to length times width times height. Again, simple volume of a rectangular prism. So then that would just be y times x. So then that would equal to y times yx squared. Usually, like, I don't know why that seems weird. I usually write it as xy squared, but I want to emphasize the order of which we're writing it in. Right? Length is longest. That may seem like common sense to you, but I've met a lot of students who are like, oh, how can we just assume that y is the length? Well, that's just because length is denoted as the longest side. That's just how it is. Um, and again, like geometry classes seem to not include this, or it's a small detail that students often forget. So that's why I'm emphasizing it, because when you're asked to find dimensions, right, it should be in the correct order. So we have yx squared, but pay attention here. Like, we're not done yet. Okay, yes, this relationship is correct. V equals to y times x, or yx squared. But it says as a function of x. So that means that this y cannot be there. It just has to be, v has to be in terms of just only x. So what does that mean? Well, it means we have to find another relationship between x, or we need to find some relationship between x and y. And this is where it can get a little confusing for students. Okay, okay, how do I find these relationships? Okay, like a little hint for you guys. The teachers will never make you do super complex geometry on this. They understand that you won't remember every single formula, every single theorem, every single day. Like, again, the geometry probably won't be that complicated, and if it is a little complicated, they'll give you like formulas. It's just like the relationships are what you really have to, like, you know, that it's still like it's a little complicated for students. But in this case, I'm gonna ease it out for you guys. I'm gonna help you guys out. So pay attention here, and I said we're gonna come back to it. So now we're coming back to it. Combined length and girth, perimeter of a cross section of 108 inches. So length, we denote as y. Again, very important. Again, I talked about dimensions here, but even since I did not include, that we had to mention any dimensions, it's still saying combine length and girth. We have to interpret what length is and what girth is. If I say h plus our girth or w plus our girth, that would not be the same as y plus our girth. So, like, we have to know that y is our length. It's the longest side. Length is the longest, okay? Please remember that. Because it doesn't say y is the length here, it just says length. Okay, that's why maybe if they didn't give a picture, they then would have to say that y is the length. Or they would have to give it to us in y by x dimensions. Okay, so again, it's like, they have to do that, or could they have said why? Yes, but again, it's important for you to know, because sometimes they won't give you, they're giving you at the same time a little bit more than you should be getting, because a picture is not for granted, but we're going to take advantage of it. So length y, girth, perimeter of the cross section. Please tell me you know what a cross section is. If not, it's just this, and again, perimeter, this, this, this. This is the perimeter of the cross section, so it'll be x, 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 and we add this. So the girth, which I'm going to denote as g, is just x plus x plus x plus x, which will equal to 4x. Okay, so our girth is 4x. Now, maximum combined length and girth of 108 inches. Combined. combined is adding. Don't we see a relationship here? 4x, which is our girth, plus our length, y, longest side, equals to 108 inches. Okay, now maybe you're confused. Maximum combined girth. How would that work? Because it says, or maximum combined length and girth is of 108 inches. Why maximum? Why does it work when it says maximum? If it just says combined length and girth of 108 inches. Well, the reason why it will work is because, and again, this will help us with the domain a little bit. Well, actually, I wouldn't. Well, we'd have to find the volume function to actually get the domain. So I mean, it's helping us with that anyway. And volume function, we can use that to find domain. But yeah, like again, it maximum combined length and girth. This function itself, 4x plus y equals 108. Y will have some, the x and y will have some value that produces 108. And that's, of course, unknown. So that's why this relationship is true, because x and y can, in fact, produce a value that will equal 108. Okay, there will be some maximum x and maximum y that will produce 108. And that, again, comes back to dimensions will maximize. Maximum combined length and girth, 108 inches. So it all connects together. Okay, so that's why this relationship works. So then, we want to eliminate this y here. We have this relationship. Let's get y in terms of x. So then y will equal to negative 4x plus, or I'm going to actually write it as 108 minus 4x. And you're going to see y here. 108 minus 4x. We have a y here, and we have a y here. So then this volume will equal to 108 minus 4x times x squared. Now this is where I'm talking about, like, why I wrote it like this is because it's much easier now to find the domain restriction. Okay, now in the last video, I was debating on the closed versus open interval, and what that means is like less than or equal to, or less than, or greater than or equal to, or greater than. In this case, I would say that for sure it should be an open interval, or the less than and the greater than should be used, because this is the U.S. Postal Service we're talking about. You have to actually have a package that exists. Otherwise, what the heck is the point of the U.S. Postal Service if no one has any actual packages? So the volume must be something that's not 0, and of course it can't be less than 0. We can't have a negative volume for the package. So that's why the logic is much more clear. We're not in the Cartesian plane. This is like an actual package does have to exist. Okay, the U.S. Postal Service will have to receive an actual package. So that's why with domain, which we're about to figure out now, will have to be with regards to an actual package. So now, again, we can guess here, or we can do the algebraic approach. I think I'm a little more lenient on, we can try the algebraic approach. I actually, yeah, we can try the algebraic approach. But keep in mind that, again, like I said, for the sake of time, really you can guess and check sort of thing with the domain. So again, I'm going to do algebraic here. So 108 minus 4x equals 0. X would then equal to 27. So I'm going to draw our number line here. Negative infinity, positive infinity. Again, because we're trying to find our domain restriction. But we have to assume we're starting on the real numbers. So and then of course 0 here. Again, this is just solving a quadratic, or solving an inequality here, because we want this to be greater than 0. Let me write this better here. We're trying to solve this inequality here, minus 4x times x squared. We want this combined, this is volume, we want v to be greater than 0. That's like our constraint. So I just talked about why. It's the actual package, United States Postal Service. Okay, so this will be 0 here, and this will be 27. The reason why I'm choosing these is because if one factor, I'm setting each factor, this factor and this factor equals 0. Because if one of the factors is 0, then the volume will be 0. And again, that's why not included open circle. Okay, just going over the whole thing here. And now I'm going to list each of our factors. 108 minus 4x and x squared. Let me put it more to the right here. X squared and 108 minus 4x. So here, this is negative infinity. Plug in any negative value less than 0. This would be positive. And then again, x squared, anything squared is positive. This is between 0 and 27. If I pick, can pick 1 here. 108 minus 4, that's positive, and then of course anything squared is positive. Here, obviously, once it's greater than 27, this will be negative, and then this will obviously be positive still. Do the multiplication. Let me write here, blue marker. So this will be positive times positive is positive, positive times positive is positive, negative times positive is negative. So this will be positive here, this will be positive here, and this will be negative here. So we want positive intervals. So it'll be from x will be less than 0, or right, x will be less than 0, or x will be greater than 0 and less than 27. So this is our domain here. We want to put in an interval notation. It would just be negative infinity to 0, union 0 to 27. That's our domain here. So again, this is the algebraic way. Again, also with sake of time, you could also sort of guess here. It can't be 0. Like each factor cannot be 0. So this can't be 0. This can't be 27. If I plug in something greater than 27, it'll be negative. If I plug in something between 0 and 27, it's positive. If I plug in something less than 0, it'll also be positive. So yeah, that's the quickest way of doing it. But again, I want to make it logically, like the logic should be clear that you can do it this way as well. So yeah, very important. Keep practicing these types of problems. Very important.